Trigonometric ratios. Before we start, let's take a moment and go over the warm-up, number 1, 2, and 3. The directions tell us to label the hypotenuse, the opposite side, and the adjacent side, all of angle A. So focusing on angle A, label the 3 parts. In number 1, let's do this one together. The other 2 you can complete on your own. Number 1, angle A is located right here. So in this triangle, the hypotenuse is always directly across from the right angle. So we have the hypotenuse located here. The opposite side of angle A is always across from the angle. And the adjacent side is always going to be next to the angle. So adjacent means next to something or having a common vertex and a common side. So opposite is always across from whatever angle you're dealing with. Please press pause on this video and complete number 2 and 3 by yourself. You're working from angle A on both of these examples. When you come back, you can check your answers against mine. Let's look at what trig ratios actually are. There's 3 trig ratios. We pronounce them as sine, cosine, and tangent. For all 3 of these trig ratios, we're going to use this triangle as our model. And for all 3 of them, we're focusing on angle A. Angle A is located here. So the sine value of angle A is always going to be the length of the opposite side so length of leg opposite angle A divided by the length of the hypotenuse. And if we label the sides, now that I talked about this side here is the hypotenuse. This side here is the opposite side. And this side here is the adjacent side. So looking at the letters and looking at this equation that I just wrote, the numerator of my ratio is the length of the leg opposite angle A. That's this side here, represented with a lowercase a. So I'm going to write my ratio as A divided by the length of the hypotenuse is represented with B. I'm going to teach you a trick on how to memorize these, but for now we're just going to go through and write down what they are. The cosine of angle A is the length of the adjacent leg. Divided by whatever the length of the hypotenuse is. So if we use our model over here, our adjacent leg is represented with C, our hypotenuse is represented with B. Our ratio would be C over B. And the last one, tangent, is always found by the length of the leg opposite divided by the length of the adjacent side. And representing these would be the opposite side, or A, divided by the adjacent side, or C. Now that we talked about what these ratios are, I'm going to tell you that trig ratios relate the sides of a right triangle to its angles. Specifically, they are ratios of 2 sides of a right triangle and a related angle. We can abbreviate these ratios as SOHCAHTOA. And SOHCAHTOA tells you what all of this is up here. So instead of having to memorize that word for word, you can memorize this statement here and what it means. So this here is telling you that the first letter, in this case S, is going to represent sine. We abbreviate it as SIN. Sine of whatever angle, let's do sine of angle A, is equal to O for opposite divided by H for hypotenuse. And that matches what we set up here, opposite over hypotenuse. Next we have CAH, pronounced as K when we say SOHCAHTOA. The C represents cosine, abbreviated as COS, and cosine is equal to the adjacent side for A divided by the hypotenuse for H. And the last part of this statement is TOA, which represents tangent, and tangent is always opposite over adjacent. So tangent is abbreviated as TAN, and this is going to be your opposite side for O and your adjacent side for A. I'm going to point out that we have these words pronounced as sine. Sine is abbreviated as SIN. We do not pronounce it as sin. Every student tries to say that. It is pronounced as sine. Cosine is abbreviated as COS. Not pronounced as cos, it is pronounced as cosine. And tangent is written as TAN, not pronounced as tan, pronounced as tangent. So make sure you see the full description versus what the abbreviation is. Okay, the first set of examples is just using the given figure to write tangent ratios. Number 1 says, what are the sine, cosine, and tangent ratios for angle T? So angle T is the angle that we're looking at. Based on angle T, we have our opposite side, and we have our adjacent side. We also have our hypotenuse. We're working from angle T. So when I write out my ratios, I'm going to write sine of angle T, because whatever goes here is always your angle measure. We don't know the angle measure, but we know we're working from T. Sine of T, based on SOHCAHTOA, S-O-H, we have opposite and we have hypotenuse. The opposite side is 6, the hypotenuse is 10. There's your sine ratio. Next, we're looking at cosine of angle T, and cosine is abbreviated as CAH. That would be adjacent over hypotenuse. The adjacent leg based on angle T is 8. The hypotenuse is 10. And lastly, we have tangent. Tangent of angle T is equal to the opposite side over the adjacent side. The opposite side is 6, the adjacent side is 8. So this statement here is so important because it tells you what to do. Now, before I say that we're finished on these, we just wrote out our ratios. But when you're done with your ratios, you should always write them in simplest form. So let's go back through. The sine of value t is equal to 6 over 10, which we can simplify to 3 over 5. And that should be your final sine answer. Cosine should be simplified to 4 over 5. And tangent should be simplified to 3 over 4. I would like to have everyone try number 2 by yourself. Number 2 is focusing from angle G. So it is not the same answer as number 1. If we focus from angle G, I'll just label your sides for you. We have a new opposite side. We have a new adjacent side. The hypotenuse does not change. So press pause on your video again, try to complete number 2, and come back to check your answer against mine. Make sure when you write your final answer it is in its simplest form or its simplest fraction form. Next, we're going to start using trig ratios to actually find missing lengths. And this is when you're given angle measures and you're going to need to use a calculator. So if you have a scientific calculator, that is very helpful. If not, you can use an online calculator, and that's what I'll be using when I go over these examples. So number 1 is a word problem. It says a section of Main Street in San Francisco rises at an angle of about 17 degrees. If you walk 150 feet up this section, what is your vertical rise? Round to the nearest whole foot. So I'll help you write out or detail this model. Remember, we are always working with right triangles. So imagine that this is the hill you're walking up. It tells you that the length of the section is 150 feet. It tells you that the angle that it's making with the ground is 17 degrees. Of course, we know we have another angle that's 90 degrees. And we're looking for the vertical rise. So if you're looking for the vertical rise, that means you're looking for how far you walked from the base of the hill to the top of the hill. What is the change in height? So we're looking for this length here, which I'm going to label as x. So based on our trig ratios, we have an option of using sine, cosine, or tangent to solve for this problem. You want to identify your angle and where it is. So we have our angle, which is here, and it's 17 degrees. Across from our angle, we have our opposite side, and we also have our hypotenuse. I'm just labeling the two sides that we have with respect to this angle. So if we have the opposite and the hypotenuse, that would be falling under the sine category. We have opposite, we have hypotenuse. So when I write this one out, which is obviously a new example, so please follow closely along with what I write, I'm going to write sine. I'm now working with a specific angle measure, and it's 17 degrees. So I'm no longer using representation here because I actually have the angle measure of 17. And this is always equal to your opposite side over your hypotenuse. And in this model, we have our lengths because we're actually solving for something. So our opposite side is x, and our hypotenuse is 150. Now you're going to treat this just like a regular problem when you're solving, and in order to solve, you're going to multiply both sides by 150. It's the same thing that you would do if you were solving for x in a basic multiplication problem. And now we need to type this into our calculator. This is going to be our answer. So I use Desmos Scientific, and what I do is I go online and I go to Google and I just type in Desmos Scientific Calculator. Okay, so once I get to this point, on Desmos, over here you see where I'm clicking, you have main, so like the bottom left side of the screen, and then all the way over is function. I'm going to select function. I'm going to select sine, and then I'm going to type sine of 17, close parentheses, multiplied by 150, because that's what I had on my paper. And over here on the right side, you can see that this is equal to 43.85. So I'm going to round this to the nearest whole foot, because that's what the directions tell me, and I'm going to round this to 44 feet. So in this case, x is approximately 44 feet. And you should write your final answer in a sentence for problems like these, but I'm just going to say out loud, the vertical rise is approximately 44 feet.